Hi, everyone. Welcome to 1.7, where we wrap up Chapter 1, an entire chapter just on solving equations and inequalities. So in 1.1, we solved some linear equations. In 1.2, we learned to apply some of those things. 1.3, we solved quadratic equations, which we extended into 1.4, where we introduced complex numbers. 1.5, we talked about all sorts of other different types of equations we can solve, right? You see 5 different types right here. And then in 1.6, we changed gears a little bit to solve inequalities. But what we saw is that solving inequalities really isn't that different from solving equations. Different frame of reference, but really similar steps. And then in 1.7, what we're going to do, solve equations and inequalities in the same section. However, this time, all we're going to do is very briefly discuss what happens when we have absolute values. So just kind of some new rules, nothing really crazy. And you're going to see it's a lot of things we've already talked about, just a step or two of setup. So let's just start by talking about some basics of absolute value. So if we want to solve an equation that is the absolute value of some expression u equals c, where c is some constant, what we're going to do is solve u equals positive c and u equals negative c. So that comes from the definition of what absolute value really means. We don't need to, at this level, really spend time looking into the theory of that kind of thing. But long story short, if you see absolute value of u equals c, you are then breaking it into two equations, one of which looks identical to the original, just without the absolute value, and the other one is almost identical except negative, whatever our constant is. So u is some expression. It's any algebraic expression, right? 5x plus 1, negative 3x plus 200, whatever it might be. And c is both a constant or an algebraic expression. So when I first mentioned it, I said, yes, this is a constant like 9 or 5, and you're going to solve an equation where it's then positive 5 and negative 5. But what ends up happening is that it works the exact same way, even if that c is another algebraic expression. It requires us to be a little careful, but otherwise it's not that different. If we have absolute value of u equals a negative constant, well, don't forget that absolute value always produces a positive number. Absolute value of 5 is positive 5. Absolute value of negative 5 is also positive 5. So there is no way absolute value of something can be negative. So there is no solution in this very specific case, right? Negative algebraic expression, that's different. A negative constant like negative 3 or negative 6, no. Like I said, absolute values can't produce negative numbers, so that's our only reason. And if we have absolute value of u equals 0, well, what you're really supposed to do is u equals 0 and u equals negative 0, but negative 0 doesn't really make any sense. Negative 0 would be the same thing as 0, so all you really need to solve is just u equals 0. So in the case where we have equals 0 on one side, we don't need to solve two separate equations. You're just going to set the inside equal to 0. So let's get right into it. And kind of like we saw in 1.5, when we go to apply some rules or when we go to apply some methods, we want to make sure that our absolute value, that our radical in 1.5, for example, is all by itself. So let's just start by adding 5 to both sides to get absolute value of 2x minus 3 by itself. Okay, there's supposed to be an absolute value here. I dropped that part by accident. So absolute value of 2x minus 3 equals 13. That splits up into two equations. 2x minus 3 equals positive 13, and 2x minus 3 equals negative 13. Again, I accidentally dropped the absolute value sign here. So this part that's highlighted right now, absolute value of this. Okay, and now what you see is, oh, that's a linear equation, and that's a linear equation. Let's add 3 in both of those two cases. Let's divide both of them by 2, and we get two solutions. Negative 5 and 8, it took one real new line of setup to break one absolute value equation into two separate ones. But aside from that, not really anything different, right? Just solving a pair of linear equations, maybe a little meaty, right? 2x minus 3 equals positive and negative 13 isn't necessarily short, but I think you guys see the method here. So let's do the same thing. We got to get absolute value of 6x minus 3 by itself. So let's start by adding 18 to both sides. Then let's divide both sides by 3. Then we have absolute value of 6x minus 3 equals 9. This is what the last equation was supposed to look like. I accidentally dropped the absolute values, but that's okay. So what we're going to get is 6x minus 3 equals positive 9, and 6x minus 3 equals negative 9. And again, from here, it is exactly like stuff we've already talked about. Let's add 3 to both sides. Let's divide both sides by 6, and we get 2 answers. So absolute value equations, not really anything super insane. Some slight new steps, some slight new setup that could be very easy to forget. But I don't think there's anything here that is really blowing anybody's mind after that setup. Absolute value of x plus 3 equals 0. So what we would do is x plus 3 equals positive 0, x plus 3 equals negative 0. But at any point in your life, have you ever written negative 0? No, you haven't. So really, these two equations are one and the same. X plus 3, I don't know why there's an extra x plus 3 equals negative 0 here. That might have been a mistake. So x plus 3 equals 0 is the only equation we need to solve. Negative 0 would, in a sense, be the same as 0. All we're doing is solving x plus 3 equals 0. Subtract 3 on both sides, and we get only one answer. And that makes sense, because if we want the absolute value of something to equal 5, well, the absolute value of 5 is negative 5, and the absolute value of negative 5 is 5. However, the only thing whose absolute value is 0 is 0. So it makes sense that there's only one possibility there. Same thing, absolute value of 4x minus 7 equals 0. Well, all we need to know is when the inside is 0, we're going to add 7. We're going to divide by 4. And I think this is pretty okay. So I know I'm moving kind of fast. I don't think any of the steps here are really screwing with anybody's mind. Okay, now 400x minus 1. The absolute value of 400x minus 1 equals negative 1. Well, don't forget, absolute values only produce positive numbers. They can't produce negative numbers. So in this case, there would be no solution. There's absolutely nothing whose absolute value is negative 1, so there's no solution. Okay, that's a pretty easy way to jump. That's kind of like what we did for square roots and even roots when it came to negative numbers. Now, I just want you to be careful, because just because one side is negative doesn't necessarily mean the equation will fail. So for example, if we have absolute value of 400x minus 1 minus 2 equals negative 1, well, all we need to do is add 2 to both sides, and now it's positive. Same thing, if we have negative on the outside, we can divide both sides by negative 1. Oh, and look at that. Just because one side is negative, make sure that there's nothing you can do to change it to be positive, right? Simple algebra like that could change you from, doing a problem that you think has no solution to a problem that has a solution. And it could also be the other way around too, right? If this was a positive 1 and this was positive 2, you subtract 2 on both sides and then you would get negative 1. So that would be no solution. But not to get too deep. So just to solve that equation, we want to solve 400x minus 1 equals positive 1, and 400x minus 1 equals negative 1. Let's add 1 to both sides. Let's divide both sides by 400. Well, 2 over 400 would just be 1 over 200. 0 divided by 400 is just 0. So we get 2 solutions there. Okay, now was all true for when the thing on the right-hand side is a constant, like 1, like 9, whatever it might be. But I also told you that it functions the exact same way, even if we have an expression on the right-hand side. So let's do just that. All this is instead of just making it a positive constant and a negative constant, all we're going to do is say 2x minus 1 equals itself, x plus 5, and 2x minus 1 equals negative the whole thing, x plus 5. So just, it doesn't really, mean so much for numbers when we say 9 and negative, parentheses 9, where we really write that parentheses 9, but it does make a very big difference when we're talking about, expressions. So be careful. It's not just negative x plus 5. It's the whole thing, negative x plus 5. So we have to distribute a negative sign. And now we have two equations again. Just got to be careful because they're going to be solved a little different. Over here, let's subtract x on both sides, whereas this one we're going to add x to both sides. Well, 2x minus x is just 1x. 2x plus x is 3x. Here we're going to add 1. Here we're also going to add 1. And then one more step for the rightmost one. We're just going to divide both sides by 3. So there we go. Again, not all that different when one side is an expression. Just be a little careful. Use parentheses. They are free. Let's do one more like that. Absolute value of 3x minus 4 equals 2 times x minus 1. So what we're going to do is 3x minus 4 equals itself 2x minus 1, and 3x minus 4 equals negative 2x minus 1. You could put another set of brackets or parentheses around these two if you want. It would end up just creating another step for you, but if that helps you see the difference, by all means, go for it. Here, we're going to distribute just positive 2, but here we're going to distribute negative 2. All right, here we're going to subtract 2x, but here we're going to add 2x. 3x minus 2x is just x, but 3x plus 2x is also just x. We're going to add 4 to both sides in each separate equation. And last but not least, we just need to divide by 5 on the right. And there we go. 2 answers. So constants or expressions make one side positive, make the right side positive, then make a separate equation where the right side is negative. That's it for both constants and expressions. Okay, what about the case where we have absolute value of u equals absolute value of v? We have a double absolute value. Well, let's apply with the rules that we have created, but let's apply them twice. And what I mean by that is we would drop this absolute value sign if we made this one positive and this one negative. I don't know why does it keep doing that? Okay, Zoom has been giving me a hard time for whatever reason on this slide. In 2 takes of recording this, it's bugged out on this slide, so I got to talk through it. Forgive me that it's not, we're not doing it in presentation wise, but here we go. So if we wanted to drop this absolute value sign, what we know is that we're going to just drop the absolute value of u, but keep the one side as itself, right? That was kind of like 2x minus 3 equals positive 9, just leaving it just like itself. But then we also solved another equation where the right side is the negative version of itself. Okay, well, that's not so crazy so far. And if we want to drop this absolute value of v, we will keep this side itself and then solve a separate equation where that side is negative itself. And same thing for over here. If we want to drop this absolute value sign, make one side positive and make one equation negative. All right, so we get 4 equations, and you would think, oh no, double absolute value, we got to solve 4 equations. Actually, not quite, because these 4 equations are really 2 equations. So what if we divided both sides by -1 in this equation? And what if we divided both sides by -1 in this equation? So that's what I do here, and that's what I do here. Okay, well, when we do that, negative u over -1 is positive u. V divided by -1 is negative v. Negative u divided by -1 is positive u. Negative v divided by -1 is v. Now, we still have 4 equations, but notice something. U equals v and u equals v. Oh, this second equation we got in the second case is actually redundant. And same thing here. We had u equals negative v, and we also got a redundant answer here. So guess what? Just like we've been solving every other equation, even when you have double absolute value, all you're solving is u equals positive v and u equals negative v. And as always, check your answers. Okay, so if we have absolute value of x minus 1 equals absolute value of x plus 5, again, one equation, one side is going to be x minus 1 equals positive version of the right-hand side, and the other one is going to be x minus 1 equals negative, the right-hand side. Again, use parentheses, be careful, and also notice not really all that different from things we've already done, but also if you wanted to apply that make one side positive, make one side negative, where you keep x plus 5 the same, you can do that too and say, oh, x plus 5 equals x minus 1, x plus 5 equals negative x minus 1. So you could technically flip one side as long as you stay consistent. So here we're just going to distribute negative 1. Over here, we're going to subtract x on both sides, and over here, we're going to add x to both sides. Well, kind of strange over here. X is going to cancel out on both sides, but on this one, x plus x is going to be 2x. Well, we got an equation here that makes no sense. That's totally fine. That means we're just going to solve this one. Add 1 to both sides. Let's divide both sides by 2, and we get negative 2. So just because we got one equation that made no sense doesn't mean the whole thing fails. It just means our only solution is coming from the second half, and that's totally fine. Let's do it one more time before we get into inequalities. So we have double absolute value, but again, all it is, one version says just drop the absolute values. Right side is positive or itself, and right side is the negative version of itself, right? It's been the same thing over and over and over again. Okay, we're going to distribute negative 1. Over here, we're going to subtract 6x on both sides. Over here, we're going to add 6x to both sides. Well, 3x minus 6x is negative 3x. 3x plus 6x is 9x. Let's add 2 to both sides. Let's divide one side or one equation by negative 3 on both sides. Let's divide the other one by 9 on both sides. And we get 2 answers again. And that brings us to inequalities. So solving inequalities is kind of putting everything we've talked about in this chapter together, right? Now, not necessarily going to use, properties we talked about in 1.1, but we are going to need to solve linear inequalities, which were like linear equations from 1.1. So putting together a bunch of different things we've talked about, from absolute value and equations and all sorts of different stuff. Essentially, putting together all of these things about inequalities and absolute values, we get 4 rules, which are kind of like 2 rules. But instead of going through all the theory to end up at these results, let's just show them off. If you have absolute value of u is less than c, we convert this to another inequality that says negative c less than u less than c. That's a compound inequality. So if you have something that looks like this, immediately jump to this. That's it. Don't try and do too much. Likewise, if it's less than or equal to, guess what? Same thing, but less than or equal to signs. Now, it's a little different from when we have a greater than sign. When we have a greater than sign, this becomes an or type of inequality. So we have regular version itself and make one side negative. But, when we made things negative, when we multiplied or divided by negative numbers, we had to flip the sign. So that actually happens here as well. So equations, we don't flip equation symbols, but when we do this for inequalities, when we make one side negative, flip the sign for that negative side, and same thing for greater than or equal to. So you might notice that these 2 rules are very similar. These 2 rules are very similar. So it's kind of like 2 things to remember, but really 4 separate rules since those inequalities are indeed unique. Okay, so 4x minus 1, absolute value of 4x minus 1 is less than or equal to 9. What we're going to do is use this rule right here. Absolute value of 4x minus 1 is less than or equal to 9 would be make this negative 9 less than or equal to 4x minus 1 less than or equal to 9. And now it's an inequality we solved in the last section. We're going to add 1 to everything, not just one part. Add 1 to everything, divide everything by 4, and now everything between negative 2 and 5 halves, including negative 2 and 5 halves, brackets around them. That's it. Not crazy, nothing scary. Absolute value inequalities. Yes, it's a very different setup from what we had for equations, but it really isn't anything different. Let's do it for greater than when it becomes an or. Okay, well, or when we have greater than, we split it up into just itself without the absolute values, and then we do itself flip the sign and make it negative. Okay, there you go. Well, now we have two linear inequalities. Let's add 8 to both sides. Let's divide both sides by 2. Let's write each of those as intervals. And now, since we're dealing with or, we're taking the union of those things. So, absolute value inequalities, not really crazy, not much new from 1.6. If you still need help solving ands and ors, check out the 1.6 video. Alrighty, absolute value of 3x minus 2 is greater than negative 5. Well, absolute values always produce positive numbers. Well, if they always produce positive numbers are always greater than negative 5. So this statement is always true. Our solution set for solving inequalities would be all real numbers, negative infinity to infinity. No matter what you plug in, this statement, this inequality will always be true. Absolute value of 5x plus 3 is less than or equal to negative 2. Well, absolute value expressions always produce positive values. So this statement is never true. If this is always positive, there's no way a positive number can be less than or equal to negative 2. In this case, no solution. That's it. So that's the end of 1.7. Like I said, 1.7 moves kind of fast. It's a nice summary of all the different tools, some of the different tools that we've talked about in chapter 1. And yeah, that leads us into chapter 2, where we really start to talk about functions and a lot of function properties. But without the ability to solve equations or inequalities, we can't talk about a lot of the different properties that we will discuss in chapter 2. So I will see you in chapter 2, and yeah, bye.
Hi everyone, thank you so much for watching. I hope this lecture helped and that you learned something. Just wanted to give the brief disclaimer that this lecture for this section is based on and adapted from the section in College Algebra and Trigonometry, the 4th edition by J.S. Ratty, Marcus McWaters, and Leswowska-Zerpek. So just wanted to give that disclaimer. I'm not affiliated with any of the authors. I'm not affiliated with Pearson, the publisher. This is entirely a presentation and lecture I created based on the book. So thank you so much for watching, and see you in the next section.